This is part 2 of lecture 1.1 of Math 108, Introduction to Logic and Negations and Connectives. In this video, we will give more examples of propositional forms involving the negation, disjunction, and conjunction operators. For each of the following propositions, we are to identify the underlying propositional form and give the truth value of the proposition. First, let us consider the statement the square root of 2 is rational, and either the square root of 2 is greater than 1 or the square root of 2 is less than 2. The smallest propositions that make up this sentence are the square root of 2 is rational, the square root of 2 is greater than 1, and the square root of 2 is less than 2. Let us denote these by P, Q, and R respectively. We now describe the abstract logical structure of our sentence using P, Q, and R and the negation, disjunction, and conjunction operators. The first part of the sentence is the statement P, followed by the word and, which signifies a conjunction. The second statement in the conjunction is Q or R. We know that this is treated as a single statement and hence is enclosed in parentheses because the word either appears before statement Q, which signifies that Q is the first sentence in the disjunction. The truth value of the whole sentence depends on the truth values of P, Q, and R. We know that P is false, Q is true, and R is also true. Thus, Q or R is true. However, since P is false, the statement P and the disjunction Q or R is false. Therefore, the given sentence is false. Next, we have the sentence either the square root of 2 is rational and the square root of 2 is greater than 1, or the square root of 2 is less than 2. We have the same propositions P, Q, and R as in the previous example. The first part of the sentence is the conjunction P and Q. We treat P and Q as a single statement and enclose it in parentheses because it is preceded by the word either and followed by the word or, which signifies that it is the first statement in a disjunction. The second statement in the disjunction is the proposition R. As in the previous example, P is false, Q is true, and R is true. So, P and Q is false, since P is false, and either the conjunction P and Q or R is true, since R is true. Therefore, the given sentence is true. Observe how this example and the previous one involve the same propositions P, Q, and R, and the same operators and or arranged in the same sequence but with different positions for the grouping symbols. The sentence in example 1 is false, whereas the sentence in example 2 is true. Thus, these two sentences are not logically the same. That is, they have different meanings. This illustrates the importance of grouping symbols. Changing their position could change the meaning of a statement. Let us look at a third example. Consider the sentence, "It is not the case that both 2 and the square root of 2 are rational." The proposition, "both 2 and the square root of 2 are rational," can be written as the square root of 2 is rational and the square root of 2 is rational. Thus, the two smallest propositions that make up this sentence are 2 is rational and the square root of 2 is rational. The phrase "it is not the case that" indicates a negation. Since it precedes the word both, this means that we take the negation of the entire conjunction 2 is rational and the square root of 2 is rational, which we treat as a single statement. Since P is true and Q is false, the conjunction P and Q is false. Hence, the negation P and Q is true. Therefore, the given sentence is true. Let us consider the sentence, neither 2 nor the square root of 2 is rational. This can be written as the statement, 2 is not rational and the square root of 2 is not rational. Let us take P and Q to be the same propositions as in example 3. Then, with this choice of P and Q, the first part of the sentence is not P followed by the word and signifying a conjunction, and the statement not Q. Since P is true and Q is false, not P is false and not Q is true. Thus, the conjunction of not P and not Q is false. Therefore, the given sentence is false. Consider the sentence, either both 2 and the square root of 2 are rational, or neither of them is. As in the previous examples, we can write the statement, both 2 and the square root of 2 are rational as 2 is rational and the square root of 2 is rational. The statement, neither of them is, means neither of them is rational, which can be written as 2 is not rational and the square root of 2 is not rational. Take P and Q to be the same as in examples 3 and 4. The proposition, both 2 and the square root of 2 are rational, is the conjunction P and Q. It is preceded by the word either and followed by the word or, which signifies that it is the first statement in a disjunction. Hence, we treat it as one statement and then close it in parentheses. The proposition, neither of them is rational, is the conjunction not P and not Q. Since it follows the word or, it is the second statement in the disjunction and thus must be enclosed in parentheses. Since P is true and Q is false, not P is false and not Q is true. The conjunction P and Q is false, and the conjunction not P and not Q is also false. Therefore, the disjunction either both P and Q or both not P and not Q is false. Thus, the given statement is false. For the next set of examples, we are to construct truth tables for the given propositional form. Assume that all letters represent unknown propositions. First, we have the conjunction not P and not Q. Since there are 2 variables in this propositional form, the truth table has 4 rows, corresponding to the 4 possible combinations of truth values of P and Q. For clarity, we include 2 columns for the truth values of not P and of not Q. The truth values of not P and not Q are the opposite of the corresponding truth values of P and of Q, respectively. The conjunction not P and not Q is true exactly when both not P and not Q are true, and is false for all other cases. Thus, not P and not Q is true exactly when P is false and Q is false. Not P and not Q is false for all other cases. Next, we have the conjunction of P and of the disjunction Q or R. Since there are 3 variables in the propositional form, there are 8 possible combinations of truth values of P, Q, and R. For clarity, we also include the column for the truth values of the disjunction Q or R. The statement Q or R is false exactly when Q is false and R is false. The statement Q or R is true for all other cases. To obtain the truth value in the final column, we only need to look at the truth value of P and the truth value of the statement Q or R. The conjunction of P and of the statement Q or R is true exactly when P is true and the statement Q or R is true. Thus, we get the resulting truth value as true, false, true, false, and so on. The rest of the table is left as an exercise. You have come to the end of Part 2 of Lecture 1.1. Before you proceed to Lecture 1.2, you are strongly encouraged to answer the exercises included at the end of these slides. Thank you for your attention.